Hey, what's up, chem peeps? Let's do one more photoelectron spectroscopy practice. The photoelectron spectra of oxygen and sulfur are shown above. Answer the following. Identify the peak that represents the 2p electrons for each element. Oh man. All right, I'm gonna do oxygen blue to match the key here. Again, realize that the height of the peak represents the relative number of electrons, and the position of the peak represents the relative amount of energy required to remove those electrons. So, for oxygen, the electrons that require the greatest amount of energy are these here, and those correspond to the 1s electrons in oxygen. My next peak for oxygen is going to represent the 2s electrons. Less energy to remove those electrons because they're in a higher energy level further from the nucleus, not held as tightly. Oxygen's 2p electrons will fall here. Those are our 2p4 electrons. Notice the peak is double the height of the 1s or 2s peaks, holding twice as many electrons. We'll do sulfur in magenta. This initial peak here represents sulfur's 1s electrons. Now notice it requires more energy to remove sulfur's 1s electrons than oxygen because sulfur has more protons, holding those electrons more tightly. Then we've got the 2s electrons, then the 2p6 electrons, followed by 3s2, finally 3p4. So I've labeled all of the peaks, but if you're just answering the question here, recognize that oxygen's 2p electrons are represented here, and sulfur's 2p electrons are represented here. Does it require more, less, or equal amounts of energy to remove 2p electrons from oxygen compared to the 2p electrons in sulfur? Explain in terms of Coulomb's law. Coulomb's law can be expressed using the following formula. Recall that the energy of attraction or repulsion between two charges is dependent upon the magnitude or sizes of those charges and the distance between those two charges. As we look to answer this question, identify the 2p electrons in oxygen, boom, and the 2p electrons in sulfur. It requires less energy to remove the 2p electrons from oxygen than from sulfur. Although these electrons occupy the same main energy level in each atom, so relative distance is about the same, the 2p electrons in oxygen have an effective core charge of +6, while the 2p electrons in sulfur have an effective core charge of +14. The lower Zeph on these 2p electrons in oxygen results in the smaller amount of energy required to remove them. Boom, done.